For the Moonmark Lunar Race Car Design Challenge, we present you our design, SwiftyBot.
The planning process was entirely held through Zoom due to COVID-19. We have no experience with CAD. We reached out to other robotic students, however, with no answer, so therefore we turned our attention to available artist, Zoe C., to draw a robotic design.
For the roles, we have Justine, who's in charge of thermal control and radiation protection. I, who is in charge of materials for building. Patrick, site steering and coding. And our outside help, Zoe C., for artistic design. For the lunar rover tires, frame, and belly pan, I researched that other science exploration and NASA used piano wire and metal strips for their tires. Tubular aluminum for the frame because it's able to withstand heat. And the belly pan, which is used to hold the electronics together. And I'm not a person who has knowledge in suspension, and I wouldn't want to do anything to jeopardize the design, so I'll just have to strap in and get ready for a bumpy ride.
For the electronics, the PID and the thermoelectric cooler will be explained in the later slide. However, for the camera, we'll be using a Microsoft Life Cam. For the motors, we'll be using the PicoBox Mio, and for speed controllers, the Spark Minis.
For the thermal control, we have the protection layers, polyethylene, nickel steel alloy, and aluminum, which reflects the heat of the sun. The PID control allows us to set a certain temperature, even a little bit higher, for the electronics to heat up, and after it gets to a certain temperature, it cools it down, shuts it off, and repeat this process over again.
For the drive control, we'll be using two motors in the front, as we believe coupling the wheels would produce unnecessary friction. For the drive software, we'll be using the graphical user interface, complete with the built-in camera function for the user to see, as we will have to encode the joysticks to divert power for steering to dictate where the bot would go. For the drive software and steering code, I previously have experience with it, and I am able to implement this into the new bot.
Onto the weight slide. On the right, you would see that we added the electronics given and the electronics we used to get the total of 3,617 grams, which left us a little under 750 grams, 550 grams, and 85 grams for our tires, frame, and belly pan.
Thank you for listening to our presentation. We're certain that our bot, SwiftyBot, will crush the competition on the moon.